This is Algebra 1, Section 1.2, Order of Operations. Our learning goal for this section is to evaluate numerical and algebraic expressions by using the order of operations. So remember to record your goal on your goal sheet. In class, I had students evaluate the numerical expression 10 divided by 5 plus 14 divided by 2. We did have people come up with different answers. And so that kind of led us to the discussion of how we needed to come up with a system so we would all come up with the same answer. So some people possibly did from left to right, and they did their 2, and then they would add 14, 16 divided by 2, and then they got 8. Some people actually did follow order of operations, and then they would have added 2 and 7 to get 9. I'm not sure if we had too many other variations, but using the order of operations, we should, again, like I said, we should get 9. So I'll go ahead and fill that in. And you can ask yourself, is that what you would have gotten? So depending on what order that we used in number 1, we said we came up with different answers. And to prevent this confusion, mathematicians have agreed upon the order of operations. And if you have the copy that I made in class, this would be a back-to-back sheet. Otherwise, you are going to have 2 different sheets that you do print out from Moodle. But here's the order of operations chart. I have the order of the steps here for you to help you along, as well as some helpful symbols or whatever, such as for the grouping symbols. They include such things as parentheses, square brackets, the square root symbol or a radical symbol, the fraction bar, and the absolute value bars. And I have you going through an example problem over here, and I do have extra notes there. So you can read through that to help you better understand the order of operations. If you have any questions on how to use the chart or information that is in the chart, please ask. Okay, so now we're going to go through some examples here on your sheet. Our first example just simply has us evaluating the expressions. And notice there's no equal sign in any of these problems, so therefore they're not equations. So we are not going to necessarily write equal signs. I'm going to encourage you highly to show all your steps by going down on the paper. Our first problem is 12 plus 5 minus 6 times 2. According to the order of operations, which I should state that other than just showing you in the chart, we do grouping symbols first. Second step is exponents. Third step is to multiply and divide from left to right. And our fourth step is to add and subtract from left to right. So by looking at example 3a here, we will see that we do not have grouping symbols and we do not have exponents. So the next thing we look for is multiplication or division. And we do have multiplication. We have 6 times 2. So the first thing we should do is multiply 6 times 2 and get 12. So now our new expression that we have is 12 plus 5 minus 12. Again, we have no grouping symbols, no exponents, no multiplication anymore, so now we need to add and subtract from left to right. 12 plus 5 is 17, so our new expression is 17 minus 12, and that's all that's left to do. We're down to one operation, so 17 minus 12 is 5. And since you are practicing order of operations, I do expect you to show all your steps on your assignment. We will later be playing an order of operations relay, and you want to be a good team member, so you need to make sure that you're showing all your steps. Just coming up with the right answer isn't sufficient. The calculator can do this anyway, but you need to know how to do it. So then moving on to example B, we do see that we have grouping symbols. Our grouping symbols are these parentheses here. So we are going to first take 15 minus 5, which is 10. So we have 10 times 2. Then that's the only operation that's left. So our final answer for example B is 20. Moving on to example C, we have 22 divided by 11 times 9 minus 3 to the second power. We do not have grouping symbols, but we do have an exponent, so we need to take that first. Please remember that 3 to the second power is not 6, it is 9. So we have 22 divided by 11 times 9 minus 9. Then we eliminated grouping symbols and exponents, so the next thing we look for is multiplication and division, and we need to do that again from left to right. So we need to first take our 22 divided by 11, and now we have 2 times 9 minus 9. We now need to do the multiplication first. So 2 times 9 is 18. So we have 18 minus 9, and our last step then is 9. Some more examples here. Little more to do in them. You'll notice in example D we have 2 sets of grouping symbols. We have the square brackets and the parentheses. When that happens, you need to work from the inside out. So since we have the parentheses on the inside, we would need to take 36 divided by 6 first. 36 divided by 6 is 6. So we have 2 times the quantity 5 squared plus 6. Now looking inside the grouping symbols, we have an exponent and we have addition. So we need to take care of that exponent first. 5 to the second power is 25. So now we have the expression 2 times the quantity 25 plus 6. The square brackets are still a grouping symbol, so we need to do our addition first. So we're going to have 2 times 31. That's all that's left to do, and our final answer is 62. The next problem, this fraction bar here, it does act as a grouping symbol. It does mean to divide. So for our first thing we need to do here then is we have essentially grouping symbols, or you could think of putting this top stuff in parentheses as well as the bottom if that helps you to rewrite it. Otherwise, we would go into doing the exponents. 3 to the second power is 9, and 4 to the second power is 16. Now, you could do it in 2 separate steps. I just took care of the exponents in 1 step. Then within our grouping symbols here, I did leave it as 16 times 2 and change it to 32. You could have also, in this 1 step, added your 7 and 9. Then 7 and 9 is 16, so we'd have 16 32nds, and that does simplify. You will need to simplify all fractions. So our final answer here for that one is 1/2, because 16 goes evenly into both 16 and 32. 16 goes into 16 once and into 32 twice. Then our last problem over here on this particular page, we have 5 squared times 4 minus 5 times 4 squared. That is above the grouping symbol over 5 times 4. I took care of the exponents first in 1 step. 5 to the second power is 25. 4 to the second power is 16. Then we would need to take care of our multiplication. I did all the multiplication in 1 step. 25 times 4 is 100, and 5 times 16 is 80, and 5 times 4 is the 20. Then we're still in grouping symbols, so we have to take care of first the 100 minus 80 to get 20, and then we have 20 20ths, and 20 divided by 20 is equivalent to 1. Then the next type of example, you have 1 more step because you're going to need to use substitution. They are going to tell you what your values are for the letters that are given. So instead of writing 2 times C times the quantity A plus B in example A, when we rewrite it, given the information here at the top, we should have 2 times 4 times the quantity 12 plus 9. We do have a grouping symbol, so we should add the 12 and 9 first to get 21. Then you multiply from left to right, so it means 2 times 4 would be multiplied first, and then 8 times 21 is 168. Our next problem here is we have 2 times the quantity A minus B squared divided by 5C. We have 2 sets of grouping symbols. And in my example here, something happened to the stuff that's underneath. So let me pause it. Okay, now hopefully I have it fixed. That just goes to show you, we all make mistakes. Not a big deal. Hopefully we'll just learn from that mistake and move on. So like I said before, we need to take care of the grouping symbol first. So 12 minus 9 is 3. Then we're going to take care of our exponents next. So we would have 3 to the second power, which is 9. Then we can take care of our multiplication. So we would get 18 20ths, and 18 20ths does simplify to 9 tenths. So 9 tenths would be our final answer there for example 4B. And then lastly over here, we have B to the second power plus 2A minus C to the second power. And we substitute in to get 9 to the second power plus 2 times 12 minus 4 to the second. Take care of our exponents first. 9 to the second power is 81. 4 to the second power is 16. Then we need to take care of our multiplication. So we get 81 plus 24 minus 16, and then we would add and subtract from left to right. So we'd have 105 minus 16, which is 89. The last example is more of a word problem that you'll see in your assignment. We have that the length of the rectangle is 3n plus 2, and its width is n minus 1. The perimeter of the rectangle is twice the sum of its length and width. We need to write an expression that represents the perimeter of the rectangle, and then find the perimeter of the rectangle when n equals 4 inches. So I suggest anytime they give you a perimeter and area problem or something where it's easier to visualize things, to actually draw the picture. So what I did first was I did draw a rectangle here and label the length as 3n plus 2, and the width is n minus 1. Then next what I did is I wrote what it said here about what the perimeter is. They told me that perimeter is equal to twice the sum of this length and its width. Then I used the fact that they told me that n is 4 inches. So if the length was 3n plus 2, we would now have, and we have another error here that we will fix here. It should be 3n plus 2. And then we would have, our width would be 3, because 4 minus 1 is 3. Then our following order of operations and using our grouping symbols, we would need to do the addition first. And we would have our 2 times 17, and 2 times 17 lastly is our 34 units. So hopefully we got that all fixed now. Not the greatest day here in recording lessons, but anyway, for our next class period, the assignment that is due is page 13, 14 through 38 evens. If you have further questions, please feel free to ask me. Thank you.